So where's the cat? There he is. So I've got a couple of little dinks in there, which I'm going to sort out for him, and it goes back into this frontier sheath there for him. So, redressing this blade, and see what else we can get on with. Thanks for joining me again. See you in a minute. Who's new to the channel, this is a 2x72 belt grinder. A lot of them are handmade in the UK because there's only a couple of companies that actually make these things. It's basically a big motor with a drive wheel driving a belt around a series of idlers. At the top will be a wheel that tracks it, which basically it sort of heaves the belt backwards and forwards because every belt's different, and it keeps it on track at the front, which is where you want the accuracy of where you're applying the blade to the belt. So you have this tracking assembly at the top which sort of steers it left and right. Okay, to change the belts easily, we don't have any guards. Now there are a few with a few little sort of covers to stop the dust and the sparks flying around, just in case the belt breaks. It might stop it coming across, but we find it easier to remove the guards to change the belt quicker. Right, so that's basically why you can see everything in the internals. You can see the wheels, you can see the handle, and you can see the drive wheel. It just allows me to do this. Off of a 36 grit, I'll explain the sizes in a minute, and then on with a 60 grit. And then you track it. Start off slow. Once you go up there a bit, back a little bit. Okay, so now it's straight. I'll bring the camera in and show you the tracking assembly. Here it is, tracking a little bit off to the left. So I want to move it so it tracks to the right. Just change the capstan on the tracking wheel so now the belt is in the middle of the plan. That's how you do the tracking. So I'll do it again, one way then the other. Turns it that way, moves it this way, turn it the other way, turns it back the other way. Now, every belt will be different, ever so slightly, and when you put different assemblies onto this, they'll be different as well. So you've got to just tune it to what you're doing each time. Intro to the Invertech. Now this is a box of tricks that takes in 240 volts single phase UK supply, and what it does is it turns it into three phase 250 volts, because the motor on the grinder is three phase. So it might want 380 or 415 volts, but it's getting 240, but at least it's getting it three phase, which gives it more torque. This box of tricks gives it that. So you'll have an on and off, which is this main switch. You can go backwards or forwards, and then the most amazing thing of all is you got this pot on the top here, which gives you variable speed. Very useful when you've got different belts, different jobs to do, where you don't want to overheat your steel. So this box of tricks you'll see quite often on people's knife grinders. The choice of speed will come into how we want to adjust the speed on that to what job we're doing. Now the job I'm doing is not a massive stock removal job, it's only to take the chips out and put a nice new edge on it. So I'm not going to start off with a really rough belt. Like, remember I said get back to grits in a minute? The grit I took off was a 36. Now if you have a look at that, that looks quite coarse, okay, quite rough. There's 36 grains of this per inch. I'm not going to use a 36 grit just to dress that up, so I've put on a 60 36 to a 60, so that it's about half the size of the grits, because I only want to gently remove the material without ruining, sort of taking off too much at one time. So let's get going on a 60 grit and make a start. Make a start is a sort of a phrase. There's a lot to do before you actually make a start. First up, you'll put your work thing on if you're going to be using the front and a jig. You could go freehand, but I'm not really a freehand type of guy. So I've now put that on there, and what I want is to get this 90 degrees. Now if you remember, I've moved it backwards and forwards to put the belt on and off, and there may be a slight change. So I'm just going to check that that's about 90 degrees. Feels right. Also, this has come on and off, so I want to check each time to give my reference point to the angle that I'm putting on this time with this belt, moving that once and this on and off. Make a start. It does take a while. Next up, digital inclometer and a 19mm. The 19mm adjusts the bolt on the back of there. This you put on to zero it before you do any fiddling about. Why? Because we just made sure that was 90 degrees. So that comes off somewhere you can find it again. This turns on and it's all angly. So that goes to there, and then I zero it, which is one of the two buttons. It's now 0. I find the 19. I put it to my super secret angle. Done. Super secret. Bite size. Now, I want to put that to that at that angle. So I use all my jigs set permanently at 90 degrees. That's what changed. These stay at 90. As that blade is already made and already coated, I don't want to mark the black coating up the steel too much, because it's very difficult to finish off and I don't want to lose too much of the black coating. So I use this one with a touch of masking tape there already, so there's less scratching, and then put one layer front and back of masking tape, so when the screws go on and make contact with it, I don't scratch the blade up too much. So let's get masking. Easy start, you know. So I end up with consistent positioning every time. It goes to there with the guard up against that side. When I do the other side, to there with the guard against that side. I would rather lead my left-handed side first, which would be this side, so that my dominant hand has slightly better skill to marry up the grind that I've done on one side with the second side. So I'm going to start off left-handed and finish off right-handed. I may get away with doing it only once each side. Okay, that's the plan. If not, doesn't matter, I'll go back the other way. So let's get going. Get some light on the subject as well. With spotlight this side, spotlight that side. Huge great LED floodlight above, fluorescent light as well. I've got as much light as I can get on it. Ideally it would be over this side because there's a window as well, but for security I've got shelving and all sorts against that window. Yeah, get it? So I'm up against this side, so I've just got as much light as I can possibly get to see what I'm doing, and I can adjust this as needed. You'll see quite a few people have removable spotlights. That's the reason I'm looking at that area with as much attention as I possibly can, and with specs, just so I can see what I've actually removed each sort of single pass, and to check I've gone somewhere each time as opposed to missed a section. I put some Sharpie pen in the area that I'm going to work on. make a start, I said. 10 minutes in, still haven't actually started. This is why when people charge however it is per inch, there's a sharpener in Bath Eastern around here, I think it's called A1, and all he does is sharpen. He must be making enough money each time, so they got to charge for doing it. So here's me, I haven't even started yet. Start, he said. Still haven't started the bloody thing yet. Nearly there. It's already heat treated. It's already tempered. The last thing I want to do is overheat that. So I'm not going to put the speed of the grinder up too fast. I'm also not going to keep the blade on the belt for too long in one place. I'm not going to use too fine a grit for too long. Okay, this is why I've chosen a 60, sort of a decent chewing belt without that fine grit which will overheat and then lose the temper of the tip as it overheats, because the metal is getting thinner and thinner and thinner and thinner, and so the chance for the heat to dissipate is reduced. So it's going to be moderate speed, and I'm not going to keep the blade in any one place there very long. Also underneath is a bucket of water, so each time I could, if I felt it, dunk the blade. Yes. Now, I'm going to use these for eye protection because I'm not blasting great loads out, but what I can do is put over specs on top of the actual vision specs. But for this little point, okay, I think we can make a start. Woohoo! Yeah. So, an even path, the tip hasn't gone yet. One more. Other side. Also, low voltage lighting, just in case the cord low voltage lighting. Belt needs to go that way a bit. Okay. Now I have a grind that has removed the chip, and it's at a point where it's almost balanced on both sides, but close enough that the next belt at 120 will actually get them even. So rather than remove even more material with a 60, I'll now go to a 120 and remove barely any material to balance it up. Things into sort of management training, saying something is a lot less time than actually doing it. So I'm going to remove the 60. We just implemented a new work ethic. How long does it actually take to implement a new work ethic? Oh, let's take some blue sky thinking on this, shall we? Ever been to those meetings? I want to work on this problem holistically. Yeah, so you sit on your whole ass while the rest of the team actually does it istically. So that's on. What have I got to do? Testing. What have I got to do now? Right, now I've got to get the tracking done on this alternative belt. One, it's a different belt. Two, that's moved backwards and forwards. It may not be exactly where it was beforehand. So, on slow, drop to the right, see? So, to the left. What do I do now? Find the belt, shut it down. Just a badge. You're getting good at this, aren't you? So, the 120 pass and the 60 on the other side. I have the 60 on one side. You may see the grit scoring on that side. This is now the 120 the other side. A lot finer. Okay, so that has now imparted a 120 grit finish on what was a 60. So now I flip it over, turn it round and go back the other way. You got it, business management meeting protocols again. Implement different work ethic to this problem. Do a little sneaky thing when you get to the finer grits. Nice. Sometimes, if this is the sort of thing a knife maker will want to do, is you just run the belt ever so slightly off the platen on the side of the plunge line, and you can finish the inside of the plunge line as you come to the end of the belt. So what I'm going to do now, as I tracked it ever so slightly that side for the first 120 pass, on this 120 pass I'm just going to track it ever so slightly this side. So, like 2 mil over. What's next then? Oh, you're getting good at this, aren't you? Nailed it! Nice. So, next task. is to give a 120 finish, a slightly better finish. But that's not what we do at Wessex Blades only. This is where you bow at the altar of all that is Kylie. Kylie Harris. Okay, on the mountain, there's a guy at the top. That's Kylie. Here's me. Here's Del. I'm there. Yeah. So, why am I mentioning this guy called Kylie Harris? Kylie was quite a tech-savvy chap from New Zealand, and he, as a knife maker, would share all of his knowledge, but in a very scientific, mathematical, methodical way, and doing things on 2D design, so he could extrapolate to the sides and show you the actual angles by clicking to the taskbar. I'm just going to do it the Wessex way. Pay attention. Class in session. Generally speaking, roughly, there are 3 grinds. 4 if you're into schisms. Okay. There is in the middle the flat grind or the Scandi grind. I'm talking in terms of the actual tip. There is the hollow grind, and there is the convex. We're only talking about the very tip here, alright, not the main bevel that you see on the knife. These are, generally speaking, the 3 different tips. Okay. Now, why I do what I do is down to what I'm going to explain in the next minute or so. With the one in the middle. Okay. And the one in the middle is the edge of what would be a Scandi grind or a Flandy grind. So this is the edge at the tip, the final degrees, the angle of what material comes up against the very edge of the blade. And if we do a line in the middle, you're going to have 90 degrees there and a bisection of whatever the angle is of that. So if this here is 30 degree Scandi, it will be 15 degrees per side. With me so far. On the convex, or in terms of the tip, micro convex, it's not that easy to do it because the angle here constantly changes, but it will be more obtuse for any given angle between this section and whatever change in angle there would be for the main big grind. Okay, this, generally speaking, will be a greater angle, so there will be more material at the very tip. With me so far. Conversely, the hollow grind, bisecting the angle, there will be less of an angle and less material than there would be on the flattish, very, very tip of the edge. So there will be less material, less steel, and less angle. So, here we go. It's going to be a dark, dark tunnel. If I was going to cut some ham in a delicatessen through material that was fleshy, softish, doesn't provide much resistance meat, I would put that on there. Steel, 55 to 60 Rockwell against meat is not really, as long as the edge is sharp, we're all assuming all the edges are sharp, would not encounter much resistance as a human being is forcing the blade that way, trying to push meat out of the way that way, and generally with a sawing action as well. Okay, but we're just going to cut straight down through. So a hollow grind, very edge through soft material, would encounter very little resistance at the start, however increasing resistance as it went down and was separated from the cells of every joining force that there is in the meat. It encounters greater resistance as it is pushed through. Meat would probably follow the line of the blade and fall away, because meat falls away. Hollow grind for a deli fish is a very good choice. Moving on to the very even, very straight edge, what would be something like a Becker BK7 has a terminal edge, okay, on a slightly leaner main grind, but the bigger grind, remove more material, the saber grind, okay, whatever it is, and then they put an edge on it. So that would be less than that. That's a greater angle than the rest of the blade. Okay, so as you're pushing through wood, which is generally what it would be used for, it's going to encounter resistance, but it won't get any greater as it goes through. It stays the same. It won't get any greater, it'll stay the same. If it was going through meat, it wouldn't increase as it was going through, but there wasn't a problem on the hollow grind because meat just folds away anyway. It's not a very resilient material. And we're on to woods. Okay, the wood could curl away. Okay, you could angle the blade as you're going, and with your own dexterity change how that is addressing the grain of the wood for carving. Very good. And the other thing is an absolute doddle with sharpen. Okay, the next one. And once again, we're only talking about the very tip. Okay, the micro convex. As it goes through material, the initial, right at the very tip, may encounter slightly more resistance than the flat grind. Will give a lot more resistance than the very tip of the hollow grind. It just will. However, we're already talking about the very tip. And there and thereafter, it will increase less and less as it goes down through whatever material. If it's meat, okay, it will stick on the sides ever so slightly more. Again, we're talking meat here, not tungsten. So as it goes, it'll encounter less and less resistance as the tip, convex micro tip, blends into the sides, and then the frictions at the sides will just blend out, whereas this will be a step here. This blends because it's a micro convex. This has a step, so the material will get to there, and then quite possibly may not encounter the rest of the blade because that main blade is a slightly leaner angle. So those work that way. For the meat that's going along here, you would hope the meat has already curled away, so it won't actually meet the sides. The sides, I see what you did there. It's very good. Wessex. So that's basically just, these are just talking points, alright? I'm not zooming in with 2D design, getting you the exact angles, we're just talking theory here. increases resistance up until a point, and then hopefully by then the material is parted in such a way as to not resist the sides. Okay. Same there, it's separated enough so it's not reaching the sides, or if it is, it's not that much difference anyway. Or there, it's gradually getting less and less. Okay, that's resistance covered. Again, we're only talking about the very tip, the very initial pushes of the blade, which in terms of force in your arm, resilience of the steel and resistance to the material will have all different kinds of formula throwing backwards and forwards. Okay, so here's the thing. In terms of magnitude, how much more effort are you using on these three basic tip edges, going through each type of material? Okay, just think about it. Going through meat, the knife, we're only talking about the very tip here. The knife will cut meat. Yeah. The knife will cut wood. Yeah, the knife will cut hardwood. Yes, it'll do it. Okay. Let's think about hardwood. So you're banging cross grain, not splitting, banging cross grain. That absolute tip there is now going through very resilient material. That tip there is going through a very resilient material. This tip here is going through a very resilient material. And this is where strength is called on far more than if it was going through meat, vegetables, spring onions, that sort of thing. If you were looking at that in terms of thickness, we could be talking thickness 0.1 of a millimetre. In terms of that as a thickness, this is just behind the edge. Let's say that is ever so slightly thicker, 0.15, and this is that same, could be 0.2. They're in keeping. That looks about half as thick as that. That looks about in the middle. These are rough numbers. Rough numbers. Now, strength is a formula there. Basically, it's thickness squared. So as the blades are going along, this atom of iron is bonded up with this atom of iron, this atom of iron, this atom of iron, and now and again you have the lattice effect of the carbon within it, usually about 1%. So you've got iron, 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 and touches of carbon. So we're just going to think about the iron, okay? This atom bonded onto that one, onto that one, onto that one. Now you can imagine there's less there when it gets to the absolute edge, because when it gets to the edge, there's nothing else for the one on the absolute outside to hang on to. Yeah. Right, so what we're going to do, I think it's thickness cubed, right? So 0.1 cubed, 0.15 cubed, 0.2 cubed. Let's get my phone out and put it on a calculator. Oh, 0.1 times 0.1 times 0.1. Clever stuff. That equals 0.001. 1.5. Let's clear that. 0.15 times 0.15 times 0.15. 0.003. I'll round it up to 4, but we're talking 10 thousandths here. I'll just round it up because that's a discipline to so many decimal places. Clear it. 0.2 times 0.2 times 0.2. 0.008. Based on the cube law, the absolute very tip of what would be a hollow grind, a flandy or scandy, or a big Becker BK7, which is a lean grind with a flat tip, or a microconvex, right at the very tip for any given thickness behind the edge, okay, it'll change as it goes through for wherever you measure it. But generally speaking, if it was 0.1 of a millimetre, 0.15 of a millimetre, or 0.2 of a millimetre, the actual strength modulus, I think it is, 0.1 cubed is 0.001. There's your 2 decimal places for each higher power. Your 0.15 would be nearly 3 times stronger. So your Scandi edge, your general purpose Scandi wood carving edge, even though it's only half as thick again behind the edge, half as thick again behind the edge, through the modulus thing, is 3 times stronger than the same given thickness behind the edge, distance it is from the very tip to where you measure it, of 0.001, which is 0.1 cubed. The 0.2, so it's only twice as thick behind the edge at any given point, wherever you want to measure the thickness behind the edge. It's 0.008. So, at the very tip, it's only a third again as thick, but it's more than twice as strong. It's only twice as thick, but it's 8 times stronger than the very tip. Now people can say, oh, no. Okay, this is why if you have a Scandi knife and you just literally strop that micro convex on it, you end up with a more resilient edge, which means it will do more work before you have to grind the whole Scandi again. This is why if you have a Becker BK7 and you strop that edge, you'll have a more resilient tip before you put the new edge on. Don't say a steel. Okay. When you see butchers going like that with a steel, all the steel is doing on your hollow grind, the ribbon of steel as the blade it just can't cope and starts just gently folding. A steel will straighten that out. That's what steel does, just straightens the edge out. So instead of a wobbly edge, looking at it really closely under a microscope, okay, now you've got a straight edge. And so resistance is not over a large area, it's on a defined point. That's what steel is for. What do you do with a hollow ground edge in order to make it more resilient for stuff to go? Oh, what do barbers do? They strop the edge of the hollow grind. It makes it more resilient. It's blinking obvious that that edge is really, really thin. But if you're shaving or cutting meat, you need a really, really sharp edge for thin cut ham, for somebody's face, or a lady shaving their legs. Okay, a hollow grind is a suitable grind for doing those materials, and you could actually increase its resilience by stropping it and then putting a microconvex edge on a hollow grind. So before all the internet trolls start bashing all over this, go and check out Knives and Stuff for his 2D presentation where he zooms in and gives you the actual maths. This is just discussion points. This is just, you know, if it would be so far, well, that wouldn't impart in sort of like assume that you'd understand as I'm going through. Just literally talking points, okay? But thickness behind the edge, if it was that, and if it was that, and if it was that, despite the fact that that is only half as thick again behind the edge, it will actually be 3 times more resilient, more strength, because there's more iron there holding on to each atom next door with the carbon inside as well. But we just assume the iron, okay? And for that being twice as strong, ends up 8 times more strength, roughly. So what I'm going to do now is put a micro convex edge on Matt's knife. Ain't that good? So that's in my head. Basically, you don't got to worry about remembering all of that in terms of something. It's just literally, if you put a micro convex edge on it, it will last longer. Is the takeaway point. So again, I am not convexing from any more than the start of that, so that microscopically that shiny edge is no longer murder flat like the carbide platen has put on it. Instead of being like that, will be ever so slightly like that, ever so slightly. Just a general stropping abrasive is this called. It's called chromium oxide. Have a look at it there. Okay, you can get that on eBay. I've had this one years. Okay, you use very little. So to use it on a blade, you can either use a belt sort of thing like you can get on the internet for razors, which will impart quite a heavy microconvex on it, because the belt gives, so you actually put that sort of obtuse edge on it, or you can put it on a flat block and then lever, and you impregnate the lever with the chrome oxide and some oil. So I'm going to mix this up and then do some stropping on Matt's tiny knife, or Matt tiny knife. Right. And notice how I'm pulling the edge across the lever as opposed to pushing the edge into the lever. I'm pulling the edge across the lever. It's all a bit thick and gooey at the moment, but eventually it sort of soaks into the lever. A very fine abrasive on a slightly forgiving surface, which is the lever, in oil, so it's sort of carried more evenly rather than piled up in great piles of dust. So keep going on this. It's in close light like this that I can see that the main grind, the bigger grind, is done on a wheel because it's hollow ground, and that's why I try not to do second-hand owned MODs. Someone says, oh, could you put one of your grinds on my MOD? When I pick it up out of the box, it's hollow ground. And it's done on a wheel as opposed to a flat platen. So I'll have to end up, that's why I'll end up sometimes going very high on one side, because how can you make that flat when that much material has already been taken from it? Okay, so on mats I'm able to put the micro edge on, the micro edge on the regrind of the cutting edge. Right. clean up a bit more. See if it cuts. Here's some oak. Can't remember what I used that for. Oh, it was the stab test for the shoe. Okay, so there's oak. That's pretty good in oak. So I'll tidy this up, put it away in its sheath, and send it on its way to Matt. So thanks for joining me. It's a sort of a vague idea on how I would put a new edge on a knife. Thanks for joining me. So if that's the sort of thing you're into, you enjoy knives, steel, machinery, guys in sheds making crazy stuff, sub to the channel, give us a like, and hopefully see you on the next one. Scott Wessex Blades.